Okay, so this section is where we get to start learning some trigonometry. So basically what this trigonometry has to do with is right triangles. And basically it's another piece to the puzzle other than the Pythagorean theorem that's going to help us find measurements of different sides of triangles as well as maybe angles. So in the next section we're going to be talking about how to actually use this to help us solve problems, but in this section we're just going to be defining the ratios. Okay, so this is all about ratios. That means it's all about fractions, okay? And you're not really going to have to do a lot of calculating in this section. It's just going to be a lot of identifying what that ratio stands for and defining what these new vocabulary words mean. So this only works for right triangles, okay? These ratios only exist in right triangles. And basically, we're going to be defining them as three different ratios, and they're going to be defined by the angle that you're talking about. In this case, we're talking about angle A. So angle A has, there's obviously three sides in a triangle, okay? It has a side that's adjacent to it, okay? It has the hypotenuse, which is the other one that will be adjacent to it. So we'll call this one hypotenuse, we'll call the other one that it's touching the adjacent, and then we'll call the side that it's not touching the opposite side. That's what these letters stand for: opposite, adjacent, and hypotenuse. The adjacent and the opposite stand for the legs. So if we were talking about this angle up here and we were called this angle B, then this side would then be called the opposite and this side would be called the adjacent because of the angle that we're talking about. Okay? We're never going to use these ratios with the right angle. Okay? The ratios only are going to go with the acute angles in this triangle, the other two. Okay? So they're called sine, cosine, and tangent. And you've probably seen these buttons on your calculator. They're called sin, cos, and tan. Okay, that's just the shorthand of it so that you don't have to write the whole word. So the sine of angle A is defined as the ratio of the length of the opposite leg over the length of the hypotenuse, or shorthand O over H. So sine of angle A is the opposite over the hypotenuse, the length of this side divided by the length of this side. The cosine is the adjacent over the hypotenuse, and then the tangent is called the length over the opposite, the length of the opposite over the length of the adjacent leg. Okay, so get these written down. I think it'll make a little more sense when once we see an example with numbers. So let me show you what I mean. So we're using angle A again, all right? And we're going to define the sine of angle A. Now, one thing I didn't tell you was that there's a, just like there's PEMDAS for order of operations, okay? There's an acronym that we use for these trig ratios that I learned when I was in high school, and I'm hoping that maybe this will be helpful to you. It's called SOHCAHTOA. SOHCAHTOA. Okay, so S, C, and T stand for tangent. The sine is the opposite in the hypotenuse. So the sine of angle A is going to be the opposite over the hypotenuse. So we need the length of the opposite leg from A. That would be 5. We need to divide that by the length of the hypotenuse, 13. So the sine of angle A is defined as 5/13. The cosine, I'm going to use my acronym to help me. That's the C, the A, and the H. That means it's adjacent over hypotenuse for cosine. So I look at that angle. I've got the adjacent side, 12, over the hypotenuse, 13. Now the tangent of angle A, okay, is going to be the TOA, the T-O-A, the opposite and adjacent. So if I look at at angle A, my opposite is 5, my adjacent is 12. So what I'd like you to do is to do the same thing but for angle B. So find the sine of B, the cosine of B, and the tangent of angle B. So this time you're not doing angle A, you're doing angle B. Okay? Think about which would be the opposite, which would be the adjacent. Hypotenuse is always going to be 13. All right? Bring that to class next time.